Welcome to session 9 of the Lawson Fuses Fuse Masterclass. Today we're going to be looking at how to read current time graphs. We're going to be looking at how to read the axes and how to read an average melt time, operation time. Let me just open up one of our datasheets which contains a current time graph. This is our Type NT Industrial Fuse Link datasheet. A few pages down here you will have the current time graph. Here we go. There's a series of lines. Each line represents the readings for a particular current rating. The different colours are just to try and help when you are tracing along the curve to find a certain point. The current rating is a figure within the line. So these figures here are your current ratings. Each one of these ratings refers to a particular curve. So 63 for that curve all the way. You will note that the axes are logarithmic scales and not linear. This is so that the scales can be compressed and you can get the whole graph onto a single page. The log scale is base 10, which means that the tick marks on the scales will go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once you get a 10, you're now in a different unit. So it's 10, 20, 30, 40, 50. So that figure there will be 50 amps. Once you get to 100, it's 100, 200, 300, 400, 500, etc. up to 1000. On the right hand side here, you'll see this is the current rating, and on the lower axis, that's the working time or melting time in seconds. Let's look at an example curve. Let's have a look at a 10 amp curve. So 10 amp is this curve here, shown by 10 amps there. What we're going to do, we're going to assume that we're going to apply 40 amps, for example, to this fuse, and I'm going to look across to see what the time is in seconds. So go to the right scale until we reach 40 amps. So that's 1, 2, 3, 4, 5, 10, 20, 30, 40. So this point is 40 amps. If we trace this along till we hit our 10 amp curve, which is there, moving down the second scale, we'll see it's 1 second. So this means for a 10 amp fuse, if you apply 40 amps, the melting time will be 1 second. Most people are used to reading graphs, but the log graphs sometimes take a little bit more practice. So just to be sure, you can check the scale readings before and after. So here is 0.1 seconds, and there is 10 seconds. So the unit there shows it's a singular 1 second. That will be 1 second, 2 seconds, 3 seconds, 4 seconds, etc. Let's try another current with the same 10 amp curve. Suppose we were to input 100 amps. This is an easy one in this case because it's the first one on the axis. But let's go through the routine. So it's 1, 2, 3, 4, 5, 10, 10, 20, 30, 40, up to 100. So this is your 100 amp point. When you move across to where that hits the 10 amp curve, it's actually the first point in that curve. Bring that down again to the seconds. So it's 0.01 seconds. So for a 10 amp fuse link, if you apply 100 amps, the operating or melt time will be 0.01 seconds. Please bear in mind that the figures shown are average times. There will be some tolerancing either side. Let's try a different curve. Let's choose 200 amps. and we'll input 500 amps into that fuse. So the curve we're looking for is the 200 amps, which is that one there, going up to this point. So we want to input 500 amps. So we'll go to the 100 section. 1, 2, 3, 4, 5. So this point here is 500 amps. Move this across till we get to our 200 point. This is our 200 curve, and it's right on that line at that point. So again, just bring this down to the lower axis. So the figure here is 100 seconds. So we can see that if you apply 500 amps to a 200 amp fuse, it will operate in 100 seconds. Okay, so that's how you read the melting time of an HRC fuse. I hope you find it interesting. Next time, I'll be looking further into current time graphs, and I'll be showing you how to read more accurate values and calculate the readings of the spaces in between the axes, tick marks. Don't forget to follow, share and comment. Thank you. Bye.